Hello, Physicsland! So, this is the deal. You guys have been going over and doing great work looking at constant velocity, finding equations, applying those word problems, looking at graphs, collecting data, all of this kind of stuff. And now we're going to apply all those ideas in the form of an actual real life scenario. And you want to see if your data collection, your equations will allow you to predict a certain phenomenon, predict something that's going to be occurring. And that's the idea of a lab practical. So, this lab practical is going to be based off of this classic physics problem of two trains at two different stations, leaving those stations at the same time or maybe slightly different times. And we want to figure out when those trains are going to collide. So, they're both on the same track. We want to avert disaster by figuring out where they're going to collide so that we can, with hopefully minimal amount of time to spare, we can switch the track over and avert this terrible disaster, terrible collision from occurring. Well, your lab practical is going to look a little different. You have two buggies that you're going to get randomly selected for you. And you're going to be given a certain distance, a certain location, and it's going to be a certain distance apart. You're going to be releasing your buggy from behind that buggy line and behind the other buggy's line. The idea is that when you release them, you want to see if you can figure out from a predetermined location that you pick. You want to see if you can figure out a way in which you're going to get those two buggies to be released and collide at as close to this location as possible. So, the idea is this: you are going to go through and collect your data. So this is a little bit of breakdown here. You're going to get two different buggies randomly selected for you. So two different buggies. You are then going to go and do your data analysis and collection so that you can figure out which buggy is going to have a certain velocity. So you're going to do the velocity calculations for your buggy E, and you're going to do your velocity calculations to figure out how fast buggy C is traveling. Once you do that, I am going to take away your buggies. So I am going to take your buggies and I am going to hide them. At that point, you are going to be given a certain starting point for your buggy. So I'm going to give you a certain mark on the ground and another mark on the ground. Okay, so two pieces of tape. And I'm going to say, okay, you're going to have to figure out a way in which you can release this buggy, one buggy, from one side of the tape and the other buggy from the other side of the tape. And you're going to determine through your calculations where they are going to collide. So when you do this, remember all of this analysis, all this work is going to be done without the buggies. So you need to figure out this point and put tape down as to where the buggies are going to collide without actually having the opportunity to use the actual buggies to go and figure out where this is going to work and where this is going to happen. So the way it's going to work then is you'll make your mark, and once you make your mark and you're ready to go, you're going to call me over. I'm going to bring your buggies back, and then you are in charge of releasing your buggies in a way that will get them to collide at the exact location that you believe they're going to collide. You're going to be graded based on this situation. You're going to be graded based on filling out and completing this lab practical form. It's 10C. You're going to be showing me all the work that you did. You're going to be going through and showing me all of your equations on this worksheet. And then you're going to go through and actually have your collision. You're going to be graded not only on your work and your procedure, you're also going to be graded based on how close you were, how accurately you were able to go and predict the location of the collision. So your grade will be based on the physics, good equations, good work, good data collection strategies, and also accuracy. Now, I'm obviously not going to throw you in right away and have you just do this right off the bat. Before you get into the actual lab practical situation, you are going to be completing a pre-lab, a preparation kind of piece here. So you're going to be doing and filling in 10A, handout 10A first. Handout 10A is basically going to be looking at this idea of having you and your friend who live a certain distance apart. You want to go and meet at Cousins. So I probably should have had it be Culver's since they're our big sponsors now. I want you to find a way to be able to get them to collide at Cousins. In other words, you want both of your cars to meet at that same location at the same time. Now, the catch is that one of you is driving a little bit faster than the other person, and Culver's happens to be a little further away than from for one of you than the other. So what you need to do is figure out at what point will you have to leave your home so that you can go and arrive at Cousins at the same time as your friend Jamie. Now, work through the analysis, and this sheet, this pre-lab, this prep is going to be a little bit more step by step. And then after that, you're going to be looking at 10B. 10B is going to look at giving you the opportunity to check the solutions that I gave for this prep activity. Once you've gone through that entire preparation, then you're going to call me over. You are now ready for your lab practical. Your lab practical is the real deal, and it's going to be 10C. So 10C from the handouts, you're going to get into a group of 3 to 4 people that are at the same point as you. And it's probably going to take about a full hour, full class period to be able to work on this. The idea then is that you will turn in one of these worksheets, one per group, and that will be the determining factor as to what your group's grade will be. So, without further ado, that is the plan. Make this happen, do great things, and I want you all to get awesome, like head on, dead on, bullseye collisions for your lab practical. Let me know if you have any questions as you go along. Otherwise, do great things and show me all the awesome things you've learned about physics and that you can deploy this and do great things with an actual lab practical situation. Have fun. Let me know if you have any questions. Bye.